I think it was page 49 through 50, and it was problems 30 through 42 even, 50, 58, 70, and 88. Okay. I'm going to go over those first. Now, I have y'all up, so if you want to ask me a question or if there's something you guys want, I can see it on the chat box is pulled up. So make sure you guys stop me if you have a question, okay? All right, so now you should just see, does everybody see a screen that looks like a board and it has 2 3s up there? Does everybody see that? Yes, okay, awesome. All right, so let's go over the problems. Question 49, page 49, question 30. Actually, I'm going to call out the answers, and then you guys let me know which ones you want me to do. How about that? All right, question 30. I'm going to call the answers, okay? If there's the one that you guys got wrong or you want me to go over, let me know, okay? So let me take it off this. Back to. Okay. Y'all see me? All right, question 30. You should have gotten x to the third plus 4x squared minus 4x plus 6. X to the third plus 4x squared minus 4x plus 6. That was question 30. Question 32, you should have gotten negative x cubed plus 4x squared minus 4x minus 9. Negative x cubed plus 4x squared minus 4x minus 9. 34 was 10x to the fifth plus 3x to the third minus 10x squared plus 6. 34 was 10x to the fifth plus 3x cubed minus 10x squared plus 6. 36 was negative 7x squared minus 3x. Negative 7x squared minus 3x. 38 was 8x cubed minus 24x squared minus 48x plus 4. 8x cubed minus 24x squared minus 48x plus 4. Question 40 was negative 2x squared plus x minus 6. Negative 2x squared plus x minus 6. And then 42 was negative 4y cubed plus 4y squared plus 4y plus 12. Negative 4y cubed plus 4y squared plus 4y plus 12. All right, any of those you guys want me to do right now? Any of those? You guys got one of those y'all want me to do? I can do one of those. 38 and 40. Thank you. All right, 38. Yep. So that one we have to distribute first and then combine like terms. So I'm going to change this camera. All right. All right, so this problem, we have 8 times 4x cubed minus 3x squared minus 1 minus 6 times 4x cubed plus 8x minus 2. So when you're looking at this problem, you have a number, this 8 is on the outside, and you're going to have to distribute this to each of your questions first before we do any moving or combining like terms. The same thing for this -6. This -6 is going to have to go to the 4x cubed, the 8x, and the -2. So be careful with that, okay? So when we do this, we've got 8 times 4, that's going to give you that 32x cubed. 8 times -3 is -24x squared. And then 8 times -1 is going to give you a -8, okay? Then we're going to distribute the same thing for the -6. So this is going to be -24x cubed. What is that? -48x plus 12. Okay, questions so far? All right, then we can line things up if you want to, or we can just kind of go across. We've got 32 minus 24. Those are our like terms. So that's going to give us what? 6 and 2, that's going to be 8x cubed. Okay, I'm just combining my like terms. Then I've got this one here. And we don't have a square, do we? So I'm going to just bring that down. Okay. Then I have an x here, so I'm going to do minus 48x. And then the last one I have is a -8 and a positive 12. And that's going to give us what? 8, 9, 10, 11, 12, positive 4. And I believe that's what we got. That was number 38. 8x cubed minus 24x squared minus 48x plus 4. Okay. Now you could have also lined these up underneath them if you wanted to. But Anna, that help with 38? All right, and then let's take a look at 40. Yes, okay. 40 was a little bit different as well. Like this one. And there might have been a sign that you missed. Simple sign messes the whole problem up. All right, 40. We've got x squared plus 1 minus 4x squared plus 5 plus x squared x minus 2. X squared plus 1 minus 4x squared plus 5 plus x squared plus x minus 2. All right. So when you're looking at this one, you've got this negative in here in between, okay? Can y'all kind of see my invisible arm here? That's pretty cool. So what I would do, because the negatives can get tricky, I would go ahead and change this to an addition and then change your signs over here. So that way when I'm lining stuff up, I already have the correct sign in front of it. So I'm looking at this x squared here, and I'm going to go ahead and line this -4x squared up underneath it. Done with that one. And I'm going to line this -5 underneath the 1. I'm done with that one. And then I'm going to look over here and see what I can line up over here. I have a positive x squared, so I'm going to put a plus x squared here. So we've got 3 there. And I have an x, so this is going to go on the end. And then I have a -2. Kind of see how I'm lining those up. All right, so this is 1 minus 4, which is going to be -3, plus 1 more, which is going to be a -2. Okay, then I have a 1 minus 5 is -4, minus 2 is going to be a -6, and then I have this plus x. Okay, and then I'm going to rewrite this so that it's in descending order. So -2x squared plus x minus 6 would be our descending order. Okay, so it might have been the sign that messed up with that one. -2x squared plus x minus 6 was our answer on that one. Okay, Anna, we good on that? Questions? Can you guys see the board a little bit better with this new camera? Do you guys like that? Or do you like it better when you could see me and all of me? I'm just curious. It's better like this. Okay, awesome. That was the point. We ordered this a while ago. We just got it in yesterday. So just the board, perfect. And you can kind of see me, but when I'm moving, you can still see the work, which is really cool. So awesome. All right. The next ones that I didn't go over, we've got 50, 58, 70, and 88. So let me go over those answers real quick. 50 50 is x squared plus 8x plus 15. These are where you had to FOIL or use the box method. Question 50 was 8x squared, x squared plus 8x plus 15. 58 was 6x squared minus 10x minus 4. 58 was 6x squared minus 10x minus 4. 70 was 9x squared minus 4. 9x squared minus 4. And then 88, I believe I gave you guys 88, didn't I? Did I give 88? Anybody know? I think I gave 88. 88 was x cubed plus 3x squared plus 3x plus 1. Oh, I did give 88. Okay, stop at 70. All right, awesome. Questions on this? Questions on questions 58, 62, 66, 76, and 78. I think I just gave y'all all those answers, right? 50, 58, 62. Oh, I didn't give you 62. Oh. 62 was 2x squared minus 3x minus 9. 2x squared minus 3x minus 9 was 62. 76 was 25x squared minus 9. And then 78 was at 9x squared minus 24x plus 16. Any questions on those? Those are using FOIL and the box method. All right, let's do the question 88 that I just talked about. I just want to do one of those with you guys real quick. It's x plus 1 to the third power. Okay, if you have one like this, what I would do first, obviously, is write this out. This means it's 3 times. And then what you're going to do is you're going to go ahead and multiply 2 of these first, and then you'll end up multiplying it by the third one. So you could do your box or your FOIL with the first 2. So you've got your x and plus 1, x and plus 1. And I've got x times x. That's going to give you your x squared, right? Because we add our exponents. And you've got your 1 times x, which is 1x. We've got 1 times x, which is 1x. And then you have your 1 times 1, which is going to be 1. Again, your diagonals are always going to be your like terms. So you end up with x squared plus 2x, because a 1x plus a 1x gives you 2x, plus 1. And then remember, you've got to bring down your other term here that we have to multiply it by. And so now we will end up having a 3 by 2 box when you multiply, or you could do your FOIL. Again, I think the box is a little bit easier. And so I would set this up as x squared, positive 2x, positive 1, and then an x and a plus 1 here. Everybody with me? And so we would do x times x squared. That's going to give you an x cubed. 2x times x is going to be 2x squared. 1 times x is 1x. 1 times x squared is 1x squared. 1 times 2x, 2x. And a 1 times 1 is 1. And then our diagonals, again, are your like terms. And so you end up with x cubed plus, we've got a 2x squared and a 1x squared. It's going to make 3x squared. We've got a 1x plus a 2. It's going to be a 3x. And you're left with a plus 1. And so that should be your final answer on a question like this. But I did want to do one of those with you guys, just to kind of recap over those. How does everybody feel about multiplying polynomials? Right, pretty good on those? Do we want to do any more examples? Seeing some thumbs up, some good. Everybody good? All right, awesome. There are some, so if you look at R4 in your book, there are some, certain type of multiplying, like difference of squares. and squares about perfect squares. I'm gonna write these down for you guys so you have them. And really for those, it's just easier to memorize them because they're your special factoring or your special products. So let's write those down real quick so you have those, and I'll kind of go over those briefly. This is the end of R4 technically, and then we're going to begin R5 today as well, which is factoring. So this is your R4 continued. This is still your notes, okay? This is pretty much the last of the R4 notes reviewing. All right, so difference of squares, it's when you have, you multiply two things that are the same and one's a positive and one's a negative, okay? So for example, if I had x plus 3 times x minus 3, that is the difference of squares products. Okay, it's the same thing being multiplied. And when you get your answer, what happens is you square the first term. This is when you factor it. And you square the last term, and it's a subtraction in between. So the middle terms cancel each other out. Those are the easiest factoring problems that you'll have. It's always a two-term. This is a perfect square, this is a perfect square, and there's a different sign in between. So difference of squares. All right, then you have stuff called perfect squares. So it's not going to have a difference in it. And it's just when you're doing two of the same thing. So it's when you're squaring something. So this will be x plus a times x plus a. And when you get it out, it'll be x squared. So you square the first term, you do two of the middle terms, you square the last term, and it's all addition. And so an example of that would be x plus 3 squared, which would just be x plus 3 times x plus 3, which would end up being square the first term. It would be 3x plus 3x, which will be 6x, and then square the last term. And that one's called perfect squares. Now, can you not see the bottom part there? Why can you not see that? Trying to see where it stops. Can you guys see? It stops at x squared plus, oh no, you can see the whole thing. Okay. All right, questions on these two? Y'all have seen these before? Hopefully. Difference of squares, perfect squares. I am recording this. So my goal is to record every lesson, and then I can go back and put it back on Moodle. So that way you guys can go back and rewatch it. So if there's something somebody missed, that's my goal. I just need y'all's help reminding me to record it because sometimes I forget. All right, the next one we're going to talk about is cubing, which I did an example of this on the homework just a second ago. Everybody good on these? Everybody got them down? All right, cubing is what it sounds like. It would be if I had x plus 2 to the third power, which just means I'm doing it 3 times. Okay, you can multiply that all the way out. And this would be x plus 2 times x squared plus 4x plus 4, and you could keep going out with it. And then you have difference of cubes, which means it's going to have a minus in it. Go. All right, difference of cubes. This is the pattern. You have a difference in the front, and then these two are both positive. Okay. So let's see. If we had x minus 1 times, and then again, it would be x squared the first term, multiply the 2 in the middle, 1 times x is 1x, and then square the last term. It would look like that. So again, it's a minus in the front, and then both of these are plus plus, and to get this part, well, you would take the cube root here, and then you square the first term, square this term, and then multiply the 2 in the middle to get that one. We're going to do some factoring of the, this is factoring technically. We're going to do some of these later, but not right this second. Okay, so this is the difference of cubes ones. And then there's sum of cubes. Still see that? All right. And that one's like x plus a, and then you have a minus and a plus. So you square the first term, square the last term, and then multiply the 2 in the middle. All right, so difference of cubes, you always have a minus here and then a plus plus. Sum of cubes, you're always going to have a plus and then a minus plus. Easiest way for those is just to memorize it, unfortunately. And this is factoring technically, we're factoring here. An example, if we did x plus 1, you would square the first term, this will be x squared, square the last term, this will be 1, and then you would have a minus and a plus, and we would just multiply the 2 in the middle. But again, I'm going to go over this with you more in depth. These are just to have. So there's actual cubing, and there's difference of cubes, and then sum of cubes. R4 also includes dividing polynomials. I'm going to wait on that for later. We don't do as much dividing polynomials. If you remember, for dividing polynomials, you would do synthetic division or like long division. So, all right, questions on these? Anybody have any questions? All right, so we're going to go ahead and move on to factoring, which is usually the least fun thing that students like. And it's one of the things that students struggle with most. So we're going to go ahead and start with that. Everybody have this down? I erase this. Either give me a thumbs up or yes. All right, thank you. Okay, factoring. Now, if you guys look in Moodle, there is a factoring cheat sheet that I posted. I would print that out because I think it's helpful. Let's take a look at it real quick. Let's see if I can share this and come back. All right, let's see. All right, can you guys see the Moodle? You know, see my Moodle page? Yes, okay. All right, so if you go to Moodle under week, we already did week 1 technically. So now that we're done with R4, you guys can go ahead and do the quiz for R4 since we finished it. Oh yeah, there's the problems I put up there. All right, so I'm gonna go, I like to try to be like at least a day ahead for in-person versus the online part. So this is R5. And if you go to which isn't open yet for y'all. If you go to R5, you will see this factoring cheat sheet down here. It hadn't opened yet, but when it does open, you guys, I would go ahead and print this out. Let's open this. Why is it not letting me? All right, here it is. All right, so this is what it looks like. So let's walk through this a little bit. So the factoring sheet, you have the first thing that you should always do is check to see if there is a GCF first. Okay. Does anybody remember what a GCF is? What does GCF stand for? Anybody? GCF. What is GCF? Does everybody see this factoring cheat sheet that I have up here? Yes, greatest common factor. Awesome. Okay. So the greatest common factor, what do they both have in common that is the greatest term? Okay. So you always pull that out first, no matter what. And then you look to see how many terms there are. Usually your polynomial is going to have either 2 terms, 3 terms, or 4 terms. Okay. And based off that, you can look at the special factor formulas, which we just talked about. This is a difference of squares. This is a difference of cubes. And this is a sum of cubes. Again, you need to know all 3 of these. Okay. If it's 2 terms and it's one of these, you can just factor it. Okay. Then you look for 3 terms. If you have a leading coefficient that is 1, you can use the guess and check method. Again, I'm going to do some examples of all of these in just a minute. I just wanted to show you the cheat sheet first. And then if it's not a leading coefficient of 1, then you would multiply the last term by the first term and then factor out, and you can do grouping or the reverse box method. Okay. And then if it's 4 terms, you would do grouping. Okay. Or you could do the reverse box, but anyway. So when we get to this, this will open up, let's see. This will open up August 28th. So today is what? The day is the 20th, so next week. So we got plenty of time here, but I just like to work ahead a little bit. All right, so you'll be able to print this next week. But again, this is due, the first quiz is due the 26th. Looks like 16 of you guys already did the introduction form, so make sure you guys finish that out. It's just to introduce yourselves. And then, like I said, the first quiz is due by next Thursday. So we're going to be, I'd like to get way ahead anyway, but we're going to be way ahead. All right. So let's look at some examples of factoring. And I got to stop sharing. Stop sharing. All right, we should be back up to the board, I hope. All right. So again, this is R5 factoring. And again, step 1 is always to pull out the GCF. So for example, if I have something like 4x plus 12, okay, how many terms is this? 2. Good. I'm seeing some fingers. 2. All right. Can anyone tell me what is the GCF of this? All right. 4. Good. Everybody in agreement. It's 4. Why is it 4? Well, you're looking for the greatest number that can go into both of these. Does that make sense? 4 can go into 4. 4 can go into 12, and it's the greatest number that can go into both. So if you were to pull this out, technically factoring, right, you would pull out the GCF first, and then what you have inside the parentheses is what you have left over. And then that's factoring. Okay, it's like working backwards. So 4 times what is going to give you 4x? What do we need? An x. Good. And then I have my plus sign. And then 4 times what's going to give you 12? Good. I'm seeing that. All right. So technically, you guys realize this is what we were doing Tuesday's class. We were going from here to here. And now today we're going from here to here. So this is what factoring is called. It's like breaking it up. Okay. And this is what we did Tuesday's class. We went from here to here. So we have factored this out as much as you can, and you're done. And that is called using your GCF to factor. Questions on this? All right, so let's do another one. Why don't we do, I want you guys to pull out the GCF of this, okay? All right, do this one. Find the GCF of this and factor it out. Pull out the GCF, factor it out. Everybody done? All right. So if I were first to figure out what is the GCF of this, okay, somebody want to give me what they got? 2x, 6x, I'm seeing 6x, 6. Get some different answers here. All right, first of all, what can go in each of these the greatest? 2 can go into all 3 of these, but it's not the greatest because 6 can go into 6, 6 can go into 48, and 6 can go into 36. So 6 is going to be the greatest. Then you need to look at your variables, okay? This one has x cubed, this one has x squared, and this one has x. So think about it. If I have 3 x's here, I have 2 x's here, and I have an x here. What do they all have in common? They all have at least a 1x. Does that make sense? So your GCF is going to be 6x. Okay, you got to know how to do this part in order to be able to factor. So I have 6x here, and what I have left over inside the parentheses is going to be what's inside the parentheses. So I take it and I say, okay, 6 times what's going to give you 36. We've got a 6. And I want x cubed, and I have 1x right now. So how many x's do I need? I have 1x, I want x cubed. What am I going to have to write with this one? X squared, yep. Okay, plus, yep. All right, 6x times what's going to give you 48? We need an 8. And I have 1x, and I want it squared. So I'm going to multiply it by x. Remember, what do you do with these exponents? When you multiply, you add the exponent. So that's why it works out. It's x to the first times x squared is going to give you x cubed. And x to the first times x to the first is going to give you x squared. Plus, and then I have a 6x, and I want a 6x, so I just need a 1 there. And so we factor this out. Now, eventually, you could check to see if you can factor this out further. You can't on this one, but you would need to check that. All right, questions so far? This is just practicing the GCF. All right. The second step is looking to see how many terms there are after you pull out the GCF. Like I said, if there are two terms, you want to look for those special products rules, which I said was the difference of squares, difference of cubes, and sum of cubes. So let's look at one. Let's say I want to factor x squared minus 9. So think about that factoring cheat sheet I showed you, right? The first step is always to look for GCF. Does this have a GCF? Do we have a GCF here? No, we do not. There's nothing in common with either one of these, okay? So there's no GCF. So then you think about the factoring cheat sheet. How many terms do I have on this problem? Two. Good, Abigail. We have two. The terms is always separated by this plus or minus sign, okay? So I have 1, 2. So then you think, okay, is this one of my special products that I showed you guys? And it's two terms. And so is this a difference of squares? Is it a difference of cubes or a sum of cubes problem? Does anybody know? Is it a difference of squares, difference of cubes, or sum of cubes? I know it has a minus sign in it, so that means it's going to be difference, correct? Is it a difference of squares or a difference of cubes? The difference of squares, good. How do I know that? Well, this is a perfect square because x times x is going to give you x squared. And it's not a perfect square. What are two numbers that are the same that multiply to give you 9? 3, right. So I know that I could easily factor this. This becomes xx. This becomes 3, 3, and I have my plus or minus sign there. Pretty easy, right? Here are some other examples of a perfect square. 9x squared minus 100. How would I factor this one? This is another difference of squares. Try that one. Factor this one out real quick. All right. Is 9 a perfect square? 3, okay? So I have a minus. 9 is a perfect square. Now that's going to break up into a 3 and a 3. I have an x squared, so that's going to break up into an x and an x. This is a minus. I'm going to put a plus and a minus. And then what about 100? Is 100 a perfect square? What's that going to break up into? Yes, Ian, 10. And then we're done. Questions on this? Pretty easy, right? Difference of squares. Let's do one more. Do that one. 36x squared minus 25y squared. I should be writing down. I should be seeing you moving your pencils. All right, so we have a difference here again, which is the subtraction here. Is 36 a perfect square? Yes, I'm seeing Bryson's answer looks perfect. So that's going to be 6. Good, I'm seeing a lot of good. Yes, so 36 breaks up into 6 and 6. The x squared is going to break up into an x and an x. I'm going to do my plus and minus. Now, could you also do a minus and plus here? Yes, you can. Okay, it doesn't matter which one you do first. The 25 is a perfect square. It breaks up into 5 and 5. And then you have a y squared here. And y squared is also a perfect square. And that breaks up into a y and a y. So we end up with 6x plus 5y times 6x minus 5y. Questions on factoring the difference of squares? Question. These are ones you're just going to have to kind of know, memorize, right? All right, another thing is if you look at two terms and you have to check to see if it is let's see, which one did I want to do first? A difference of two cubes. Let's look at that. Guys, hold on just a minute. I got to take this because it's a doctor's call from. Hello. This is she, yes. Yes, I'm teaching a class right now, so I'll get done in a few minutes and I'll send it again. Okay, thank you. Bye. All right, so this one, again, you have two terms. There's no GCF, okay? And so then you look to say, okay, is it a difference of squares, difference of cubes, sum of cubes? Well, it's definitely not a difference of squares. Why? Because squares means it's a perfect square. There is a cube up here, there's a minus here, and then you have to look at this number. Is that a cubic? Okay, meaning is there's three numbers that are the same that can multiply to give you that number. What do you guys think? What would it be? This is, if you took the cube root of this, it would give you x, right? And Anna's correct. 1 times 1 times 1 would still give you 1, correct? Okay, so then you have to know how to factor this. Well, this is where it comes into our, I don't know if you guys remember, it was like x minus a, and then it was x squared plus xa plus a squared. This is the form of it, okay, that I told you guys you're going to have to memorize. So the way that we use this to get our answer, well, all you do is you take the cube root of this to get our front part. What's the cube root of x cubed? If I took the cube root of x cubed, it would be x, correct? And then what's the cube root of 1? It's going to be 1. And then you put your minus sign in the front. This is for difference of cubes, okay? And again, we know it's difference because it has a minus sign here. To get the rest of this, I like to go ahead and put my signs in there because I know this first one's going to be minus for difference of cubes. These are both going to be plus. And then the way that I fill it in is you square the first term, that goes here. The last one is you square this last term. So 1 squared is going to be 1. And then to get the middle term is you just always multiply these two. So this would be 1x. And then you factored it. Everybody with me? All right, let's do another one. Let's do 8x cubed minus, let's do 27. 8x cubed minus 27. All right, so again, how do I check, right? We have a minus here, okay? It's either going to be difference of, you're going to check for difference of squares. It's not going to be a difference of squares because this has a cube on it. You're going to look for difference of cubes or sum of cubes. I know it can't be sum of cubes because there's a minus sign here. So I'm going to check to see, is this a difference of cubes? So how do I do that? Well, you look at this number. Can I cube this? Is there a number that breaks up as a perfect cube from 8? What is a number that there we go, Anna. Okay, so 2 multiplied 3 times would give you 8, correct? So if I took this, this will be 2. All right, and x cubed breaks up into what? An x, correct? So this first term would be 2x because I just take the cube root. You think about it like this, it's 8x cubed, you're going to take the cube root of that. So a number that gives you 8 3 times would be 2, and a number that gives you x cubed 3 times would end up being x. So this would just be 2x, okay? So 2x, and then I do my subtraction, and then the cube root of 27. Is there a number that multiplies 3 times that gives you 27? Good, Finley, 3. Okay, so I factored my first part, and once you get the first part, then you can get the rest of it. How do we get the rest of it? Well, remember, the first sign is going to be minus for difference of cubes, so then this other part's going to be plus. And to fill it in, I square the first term, so what would be 2x squared? 2x squared. Good. 4x squared. Okay, that goes there. I square the last term. That's going to go here. What's that going to be? And you've got to square the negative. Good. Everybody's put 9. Awesome. And then the middle term is you're just going to multiply this 3 times the 2x, which is going to be 6x. And we've just factored the whole thing. Okay, does everybody see kind of why this is a little bit tricky? Difference of cubes can be a little bit tricky. Sum of cubes can also be a little bit tricky. The only difference is the signs. Difference of cubes always is going to have a minus and then a plus, where sum of cubes is going to have a plus and then a minus plus. All right. All right, we're going to stop here for today. I will do, well, we could do a sum of cubes. Let's do one sum of cubes real quick. We got 2 minutes, so let's see. All right, here's a sum of cubes. It's the same thing, right? 8x cubed plus 8. There's a plus sign here. This is a cubic, and this is a cubic, right? So the only difference is you're going to have a plus here and a minus plus here. Does that make sense? That's the rule, all right? This was the rule for, see that? X squared minus XA plus A squared. Okay, that was the rule. So for this one, I am going to cube root this. So that's going to give me an X. I'm going to cube root the 8, which is going to give me a 2. And then I square the first term, which goes here. I square the last term. So 2 squared is going to be 4. And in the middle is I just multiply the 2 times the X. And I factored that one. So it's really the same process. The only difference is your signs are different for sum of cubes. And again, the best way to do these is just to memorize that formula. Okay, so this is sum of cubes. The other one that I wrote was difference of cubes. And then the difference of squares is pretty easy. All right. All right, we are going to stop here. Let me give you guys a few problems to do on this. Hold on, let me give you a few problems to work on factoring on these special products. So let's do page 58. Everybody see that? Page 58. Let's do 20 through 26 even. 20 through 26 even. 32. 38. 40. And 42. And I'll put that in Moodle as well. Can everybody see that? Page 58, 20 through 26, even, 32, 38, 40, and 42. And we can go over that on Tuesday morning. Okay? Hope you guys have a wonderful weekend.